Welcome to our series on pre-calculus. We'll discuss how do we find equation from the given graph, especially for rational functions, which include all kinds of asymptotes and wholes. In case you want to learn from me, you can always join my classes by sending an email on the address given. Let us now enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. There has been request from many students to understand how do we write equation from the given graph, especially for a rational function. So in this video, we are going to consider 4 examples, graphs of which are shown to you. We'll try to analyze the graph of these rational functions and then write down an equation for each one of them. In this process, you will learn about wholes, vertical asymptotes, horizontal asymptotes, oblique asymptotes, intercepts. How do we really analyze the graph? With complete understanding, you will be in a position to write down the equation from the given graph. In case you want to learn from me, you can always send an email on the address given. So these are the 4 graphs which we are going to look into. As you can see, some of them have wholes. These 2. A straight line could represent a rational function. We have horizontal asymptotes, vertical asymptotes, oblique asymptotes. So all combinations are there. So if you could analyze these 4 graphs, you will be in a position to answer most of the questions. Let's take them one by one. The very first one here is a straight line with a hole at a point 3, 1. How do we write equation for this particular graph? So let's identify what is given to us. So as we can see, we are given a hole which is at 3, 1. So that is the hole which we are looking at, 3, 1. And then we are given a straight line. The straight line equation we can find using the y-intercept and the slope. So the equation y equals to mx plus b, slope being, because the x and y intercepts are both giving you a slope of 1 unit. So it is x and the y-intercept being minus 2, x minus 2. So that is the equation of line. However, when we are considering the rational function, so let's call this rational function as ax. So the rational function a of x will be what? We are left with this line which is x minus 2. But we do have a hole here also. This hole is basically showing you a common factor in numerator and denominator. So x minus 3 over x minus 3 is that common factor. You get the idea. Now we have a restriction that x is not equal to 3 because at 3 we have a hole, and therefore we have our result here that the rational function which represents this graph is x minus 2 times x minus 3 over x minus 3. where, of course, x is not equal to 3, which results into the whole. So I hope this process is clear to you. So from the line and the whole, we could get the rational function. And the fact is, when do we see a whole? So the idea of whole is we have a common factor in both numerator and denominator. That cancels. So that is how we get a whole. Perfect. Now let's move on to the next question, where we'll learn slightly more. And this time, in addition to whole, we have asymptotes also. I would like you to pause the video, answer this question, and then look into my suggestions. So what do you notice here? Well, we have a whole also. Let's identify the location of whole. The whole is shown at a point which is at 2. We have a value which is 2. So whole is at 2, 2. So we can write down that this whole is at point 2, 2. And we have two asymptotes. One of them is the horizontal asymptote, which is y equals to 1 in this case, and the vertical asymptote, which is x equal to minus 2. So these are the two asymptotes given to us. So we have horizontal asymptote, which is y equals to 1. This horizontal asymptote indicates that the ratio of leading coefficients in numerator and denominator is going to be 1. And the degree of numerator and degree of denominator is exactly same. How about the vertical asymptote? The vertical asymptote is x equals to minus 2. That will give us a factor in the denominator, right? Let us also find the x-intercept. So we have an x-intercept right there. X-intercept is at minus 6. And the y-intercept, this is the y-intercept. So this position x-intercept is at minus 6, 0. The y-intercept is at 1, 2, 3, 0, 3. Right? So we have y-intercept at 3. Perfect. So that is the information which we have gathered from the graph. Now let's write down this function. Let's call this b. Now since we have a vertical asymptote at x minus 2, there will be a factor in the denominator which will make that 0 at minus 2. So the factor has to be x plus 2. We have a whole at 2, 2. That means there is a common factor which cancels, which is x minus 2 and x minus 2. Does it make sense? Perfect. Now we have an x-intercept which is minus 6. That means if I substitute x equals to minus 6, I should get a 0, right? So that means there is a factor which is x plus 6 in the numerator. You get the idea. Now all this gives you the idea of how the rational function could look like. Now it can be multiplied by the value a, and then we can now look into the y-intercept, a point. For that point to exist, what should be the value of a? That is what we are going to look into. So if I substitute 0, I could get a 3. So let's try to solve this equation. I want 3 when x is 0, right? So 3 equals to a times 6 times minus 2 over plus 2 times minus 2. Now there's no need to write minus 2 as they actually cancel, right? So what we get here is 3a, and that implies that a is equal to 1. Since a is equal to 1, we can now finally write down our function, and we have this function b of x, the rational function, will be x plus 6 times x minus 2. Now x minus 2 cancels, so we need not write this. Perfect? Right? But anyway, you may include it in the final answer as your whole is there, so you have to write it, and we can write this as x plus 2 times x minus 2, right? Now sometimes it may be required to write these equations by expanding, right? So in standard form. So you might do that if required. So we do have our final answer, which is that the rational function representing the graph is actually shown here, which is x plus 6 times x minus 2 divided by x plus 2 times x minus 2. And of course, we have two restrictions here, and these are that x is not equal to plus and minus 2. Is that clear to you? One of them leads to the vertical asymptote, the other one leads to the whole, as shown in the graph. So I hope with this, the complete concept is clear to you. Perfect. In case you want to learn from me, you can always send an email on the address given. Let us now move on to the next question, which is, now this time you see that the graph is slightly different. We have a graph in the center, which is kind of crossing the horizontal asymptote. Now how do we write this equation? Procedure is exactly same. Let's go for the vertical asymptotes. Now the vertical asymptote is at x equals to, this value is 1, 2, 3. The other one is at x equals to minus 1. So these two vertical asymptotes will give you factors in the denominator. So let me write down the third equation, c of x, kind of straight away, right? Now you know how to do it. So these two vertical asymptotes will give me a factor in the denominator, x plus 1 times x minus 3. So that is clear to you. Now, let us look into the x-intercepts. So this x-intercept is at minus 2, right? And the other one is at 2. So these are the two x-intercepts. So they come in the numerator, x plus 2 times x minus 2. Now we look into the y-intercept. The y-intercept is at, it is at 4, right? So y-intercept is at 4. So we have y-intercept at 4. And let's look also into the horizontal asymptote, which is at 3. So y equals to 3 is your horizontal asymptote. So we have a value of a right there, and we will see that the a should be equal to 3. Since the ratio of these two is basically 3, you get the idea. So I know a should be equal to 3. Since we have this horizontal asymptote at 3, so the ratio of numerator and denominator has to be 3. So 3 comes in. Now let us check using the y-intercept. The y-intercept is at 4. So if I substitute 0 here, so what is c of 0 equals to? Let's calculate. 3 times 2 times minus 2 divided by 1 time minus 3. And what we get? We get 4. So that is correct. So that means that the equation is absolutely correct. You get the idea. So we wrote the equation using the intercepts and the asymptotes. and we checked it with y-intercept. Good idea. So that becomes our strategy. So here we have evolved a strategy, and that is check result with y-intercept. Does that make sense? Perfect. We're going to use this strategy in the next example. Okay. In this example, we have an oblique asymptote, right? So we have a case of an oblique asymptote. How do we get this equation? We also have a vertical asymptote, which is here. Correct. So that is the vertical asymptote. Let's write down the equation. The vertical asymptote is shown as x equals to minus 1. We have x and y intercepts shown here. So this is at the origin, right? And that one is at 1, 0. So we have two x intercepts, one at the origin and the other one at the point 1, 0. Let us find the equation of oblique asymptote. To find the equation of oblique asymptote, we can check the x and y intercepts. We see that the slope is 1 for it, right? Rise over run. So 1 for it. This point here is minus 2. That point is 2. And therefore, we have an oblique asymptote. Let's write down the equation. Which is y equals to slope being 1, x minus 2. So that is the oblique asymptote for us. As far as the x and y intercepts are concerned, we have origin and 1, 0, and we have, let's call this function as d of x, and let's begin with the denominator, which is clearly x plus 1. Since we have a vertical asymptote at x equals to minus 1. Clear? Now, degree of numerator has to be 1 higher. Now, let's figure it out. We have these two x-intercepts. Clearly, we have two factors in the numerator. One is x, the other one is x minus 1. So, with these two factors, we do get an equation for the given graph. You get the idea. So, that could be our rational function. Now, let us check for oblique asymptote. So we could expand this equation, which is x squared minus x, and dividing this by x plus 1. Let's see what do we get. I'm placing a 0 as a placeholder. So we could write this as x, and we get x squared plus x. So if I take away, I get minus 2x plus 0. So minus 2. As you can see, we have confirmed that the oblique asymptote is exactly what we expected from the given equation. So that becomes a check for us. And therefore, we know that the given equation is the equation for the graph. Does it make sense to you? So we finally have an equation which has been checked for the oblique asymptote. So you write this as x squared minus x over x plus 1, or in the factored form as shown here. So I hope with this you understand how do we write equation from the given graph. So with that, let me conclude few things which we have learned. When we say wholes, it really means common factor. When we say vertical asymptote, denominator equals to denominator equate to 0. Horizontal asymptote, we have seen horizontal asymptote is basically coefficient of numerator and denominators, right? So it's coefficient of numerator over denominator, leading coefficient, correct? And for this horizontal asymptote, the condition is that, let me write down here, for horizontal asymptote, degree of denominator is equal to or greater than the degree of numerator. Now, as far as oblique asymptote is concerned, we have degree of numerator is 1 more than denominator. Clear? So that gives you the oblique asymptote. Intercepts. Intercepts we've seen. X-intercepts will give you factors in numerator. Clear? Y-intercept we have used to check. Check for A value. Is that okay? Check for A. So that gives you a good idea about how we could actually write down the equation from the given graph. I hope you find it interesting and useful. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.